So this is the review for Power Standard 5 for college algebra. I was going to do a lot of solving in this Power Standard. All right, first thing we have come up is solving quadratic equations. All right, the first one is where you could solve using square roots. All right, what you're going to do is you're going to add 9 first to get the squared part by itself. So we have x plus 8 quantity squared equals 9. Then to get rid of that squared, we're going to square root both sides of our equation. The squared and the square root will cancel each other out. You get x plus 8. When you take the square root of 9, which is 3, you have to remember to put plus or minus. There are 2 possible answers for that question. Next, we're going to subtract 8 from both sides. So x equals negative 8 plus or minus 3. But because we can keep going, we do have to. Okay? If this is like the square root of something, plus or minus is something else, then you could stop. But we have 2 whole numbers or 2 integers. We got to keep going. So if we keep going, negative 8 plus 3 is going to be negative 5. And then negative 8 minus 3 is going to be negative 11. And those are your 2 answers. All right, next we have a factoring problem. Okay, it's going to be like an advanced factoring or a bottoms-up method. So what you do for both is you take 4 times 1, which gives you 4. You got to find 2 factors that will multiply to be positive 4 but add up to be negative 4. Those 2 factors are negative 2 and negative 2. If we do the bottoms-up method, which is what I'm going to do next, you're going to take the leading term, the leading coefficient, which is 4 in this case, and put it as a denominator underneath your 2 factors. You can then reduce your fractions. You get negative 1/2 and negative 1/2. You put an x in the denominators for both, and move that up to become the first term of your factors. So you have 2x minus 1 and 2x minus 1. Now, this is a solving problem, not just a factoring problem. So you actually have to take these 2 factors and set them equal to 0 and solve for x. So you're going to add 1 and divide by 2. Since it's both the same thing, we only need to do one of them. And that is your answer. And number 3, we can do a couple things. You could do solving using square roots. What I'm going to do, though, is we're going to take the greatest common factor of 3 out, which leaves me with x squared and negative 16. And then I can take the x squared minus 16 because that is a difference of 2 squares, because x squared and 16 are both perfect squares. I can use that as factor pieces of x minus 4 and x plus 4. I'm going to take our factors and set them both equal to 0 and solve for x. There you go. All right, next, solving absolute value equations. Now in absolute value equations, because you can have 2 separate answers coming out of absolute value equations, one being positive, one being negative, and they will both become a positive answer, you have to account for that when you're solving these. So you're going to make 2 separate equations. X plus 1 equals 9. Sorry, 4x plus 1. And then 4x plus 1 equals negative 9. And now we just solve them both. We're going to subtract 1. Gives me 8. And 4x equals 8. And x will equal 2 when you divide both sides by 4. The other side, I'm going to subtract 1. You're going to get negative 10 equals 4x. When I divide by 4, you get negative 10 over 4, which can be reduced to negative 5 over 2. Now, technically, you should check your answers in absolute value equations, but unless there's an x on the outside of your absolute value brackets, you don't really need to at this point in time. So we're good. Next question, number 5, is a radical equation. Okay, to solve these, you want to square both sides of your equation to get rid of that radical sign, because the squared and the square root will cancel each other out. You have 2x plus 3 is equal to x squared. Now this is going to turn into a quadratic equation by subtracting 2x and subtracting 3 to the other side. Now the reason you don't want to do the x squared to the other side by subtraction is because you'd rather not have your leading coefficient in your x squared be a negative number. So we're going to leave it just like it is. Okay, so we have x squared minus 2x minus 3 equals 0. Now we can work on factoring this. All right, so 2 factors that make up negative 3, but that multiply to negative 3 but add up to negative 2 are going to be negative 3 and positive 1. We set both of our factors equal to 0. Oops. And solve for x. All right, next we have a rational equation. To solve rational equations, first what you have to do is factor them. So we're going to factor the top and the bottom of our fraction. So we have x plus 3 and x minus 2 on the top. On the bottom, as a difference of two squares, we're going to have x plus 2 and x minus 2. All right, the reason we did this is we want to find out if any of the terms of the numerator or the denominator are the same, that we can then cancel, which we can in x minus 2's. All right, now to solve this, all we want is the top piece. We don't care about the bottom. We just want the top. We set x plus 3 equal to 0 and solve for x. That's the only part we want. Number 7 is a chemical mixture problem. We're going to make some buckets here, some bins. So we have a bin here. Our chemist friend has a 30-gallon solution. It is 40% vinegar. He's going to pour 15 gallons of pure vinegar into the solution, so we're going to add 15 gallons of pure vinegar. Now, the pure part of the vinegars is an important contextual clue. If it's pure, that means it must be 100%. Okay? Again, I would have tried to say this during the video for this particular lesson. If you're drinking something that's not pure water, you have to ask yourself, well, what else is in it? All right. Anyway, we want to know what the resulting solution is going to be. We're looking for what the percentage of that resulting solution is. So that's going to be our x. And we do know that since we're adding these 30 and 15 gallons together, that's going to give us a grand total of 45 gallons. Now we multiply down. So 40 times 30 is 1,200. 15 times 100 is 1,500. And that equals 45x. We combine the two terms on the left. We get 2,700 equals 45x. Divide both sides by 45, and we get, I'm not sure, we get 60. 60% is our resulting mixture. All right, moving on. Now we have an absolute inequality, absolute value inequality. And this, they work very much like the absolute value equations we did above. We're going to have two separate answers, or two separate equations, sorry. We have a less than 3. That should be a 3, not a 2. And we have a 3x plus 3 is less than negative 3. So what we do is we change the answer to become a negative, and we change the inequality sign by flipping it. Okay. Now we solve them both. Subtract 3 gets us 0. Divide by 3, and you will get, again, 0. You subtract 3, you get negative 6. Divide by 3, and you're going to get negative 2. Now, one quick thing. We are subtracting 3 in this second part of the problem. We are not dividing by negative 3. All right, so because you're subtracting, that doesn't change the inequality sign. If you were to divide by a negative number, it would flip the inequality sign. All right, now we've solved our problem. Now we're going to graph it on a number line. So we have negative 2 here and 0 there. The negative 2 is a parentheses going to the left, and the 0 is a parentheses going to the right. Now, before we move on from there, I want to make sure that what we're graphing is actually correct, because we can figure this out by looking at the inequality sign up here. This is a greater than sign, a great or, versus a less than. All right, so that works as an or question. And the last piece that we want to do is do the interval notation. So since our negative 2 is going to the left towards negative infinity, that's where we're going to start our interval notation, going towards 2. And we have our break with our symbol, starting up at 0 with a parentheses again, going towards positive infinity. So when we're doing these problems, we want to have these three things. the answers, the number line, and the interval notation. Okay, number 9. This is a more complex compound inequality. All right. Now, in a complex compound inequality, what you have to do for these is you can't solve them like the simples because you have too many x's in the problem. So what you're going to do is divide this into 2 pieces. Okay, you're going to have the left side of the inequality. You're going to have the right side. All right, so we're going to solve these independently of each other and then put them back together later when we do the number line. First, we're going to add 4, gives us 16, 4x. Divide both sides by 4, and you're going to get 4 is x. There we go. Okay, on the other side, we're going to subtract 3x. We're going to add 4. Gives us x is greater than 12. Okay. Now in this case, what we have, so we're going to draw our problem here. So we have 12 over here. It's going to the left. We have 4, which is going to flip around. It goes to the right. Or sorry, 12 goes to the right. The 4 is going to go to the left. I'll get my directions down. All right, but here's an issue. A compound is a AND equation. This should be an AND. And the way this is shaping up is not an AND, so this would be a no solution. Okay, but you'd still need these 3 pieces. All right. Moving on. This is a more simple compound inequality, unlike the last one, which was a complex. All right, and this one, because it has only 1 x in it, you can solve both sides at the same time. Now, you could break it up like we just did with question number 9, or you could keep it together. So, if we kept it together, we could do subtract 5 from both sides, which gives us negative 10, 2x, and that would give us 8. Then divide everything by 2. So negative 5, x, and 4. On our number line, we have 4 going to the left and negative 5 going to the right. We'd be going shading in between those 2 things, and that's good because as a compound, again, this is an AND question. And then for our interval notation, I'm sorry, that's negative 5. We'd have negative 5 with a bracket to positive 4 with a bracket. And again, you'd want to have these 3 pieces: the answer, the the number line, and the interval notation. All right, onward. And number 11 and 12, these are the questions from Standard 1, Power Standard 1. And Power Standard 1, all you have to do is draw the pictures and maybe set up the equation. But this, you actually have to solve it. So we're going to draw the picture to solve it anyway, so let's get going. So we have a rectangular picture, has the dimensions of 8 inches by 6 inches. So here's our picture. There's 6, there's 8. All right, and has a frame around it of uniform width. If each side is x of the frame, then this is going to become 2x plus 8 and 2x plus 6. Okay, because each side is x. So if you add across, x plus x is 2x plus 8 is the width, and then x plus 6 is 2x plus 6, which is the height of the rectangle. So now we can make our equation. If we're finding the area, we have 2x plus 6 times 2x plus 8, and that equals the area, which is the area of the frame itself is 32, plus the area of the picture itself is 48. So now we can start combining our like terms and multiplying things together. So we have 2x times 2x is 4x squared. 2x times 8 is 16x. 6 times 2x is 12x. 6 times 8 is 48. And 32 plus 48 is I'll get it. 80. All right. Now I want to bring the 80 to the other side, so we set it equal to 0, and then combine some of these other terms. We got 4x squared plus 28x. 48 minus 80 is going to give us negative 32. Okay, so now we have our equation. This is our quadratic. Now, the nice thing about this quadratic is all these terms that have a 4 in them, we can take it out. We have x squared plus 7x minus 8 equals 0. Now we can factor that much easier. Okay, so if we two terms that multiply to give you 8 and add up to give you positive 7, it would be positive 8 and negative 1. Now we take those factors, set them equal to 0, and we get x is equal to negative 8 and positive 1. Well, you can't have a distance of a frame that is negative, so the 1 is your answer. So each frame is 1 inch wide. Yep. All right. Number 12, this is a parabola type problem. So again, we want to draw our picture. All right, there's our picture of a parabola. If the dish is 12 feet across at the opening, that means each side is 6 feet. That means this point right here is 6, 0. This point is also considered x, y. All right. Next, we know that the height of the dish is 4 feet. So this point is the vertex, which is going to be 0, 4. So now what we're going to do is we need to find out what the focus point or the focal distance is going to be. We need to find the p of our equation. So I'm going to write down the equation for the parabola that we're going to be using. So it's x minus h, quantity squared, equals negative 4 times p times y minus k. So now we have the x and y. This point up here is our h, k. So we're going to put these values into our equation. We're going to have to solve for p. So the x is 6, the h is 0, so we don't need it. Minus 4 times p times the y is 0, minus 4 is the k. So that's our equation. So now we just have to solve for p. So we have 6 squared is 36. Negative 4 times 4 is 16p. We're going to divide both sides by 16. So p will be 36 divided by 16 is 2.25. Let's make this a prettier number. There we go. All right, we're on to some exponential equations. All right, this is where the bases are the same. So that means that the bases are the same, you can cross them out. You just take your pieces, or sorry, exponents, 14x plus 8, and set it equal to the other exponent, 10x minus 20. And then you can solve this equation for x. We're going to subtract 10x, subtract 8. Gives us 4x is equal to negative 28. Divide both sides by 4, and x will equal negative 7. Here we want to solve this equation. So it's a logarithmic. We want to make it an exponential equation. Now, since there is no base for this log, it is automatically a 10. So we smash the log and bring the base over to the other side. We have 10 to the 5th as the exponent equals x. And x will equal whatever 10 to the 5th is. Let's find that out. 10 to the 5th is a lot. 100,000. Okay, so the log gets smashed. The base of the logarithm goes over, becomes the base of the exponent on the other side, and that equals whatever is next to the log. Here we have a problem just like 13, but it doesn't have similar bases, so you're going to have to change the base. Okay, in order to do this, you're going to find something that both 4 and 16 share in common, that is a base that you can change something to an exponent. So the good thing is that 16 is the same thing as 4 squared, but our squared is going to be on the bottom of our fraction, the 4 squared. So we have to move to the top. So what happens is we change the exponent of 2 to become negative. Okay, and that moves it to the top of our fraction, so it's just 4 to the negative 2. Now, if you're not sure, you don't believe me, you can always put 4 to the negative 2 power in your calculator. It'll give you 1/16, or the decimal equivalent of it. Well, now that we have the bases being the same, we can cross out the bases just like we did in the question right above this, and then set the exponents equal to each other, which gives you x equals negative 2. Now in 16, it's a little bit different because unlike the exponential equation we've been doing the last 2 exponential equations we've done, these don't have like bases, and they're not going to have like bases. So we're going to have to actually use logarithms to solve this. So what we're going to do is we're going to change this to a log problem. So the x as the exponent becomes the coefficient. We're going to put log of 4, and that's going to equal log of 20. Now to solve this, we want to solve for the x. We're going to divide both sides by log of 4. All right, those will cancel, and you'll get x is equal to whatever log of 20 divided by log of 4 is. Now it's important that when you're doing these that you put the denominator, the log of 4, in parentheses. So we have log of 20 divided by, I'll put in parentheses, log of 4, which gives you 2.16. All right. Now we have something with logs where it's going to be a combination of stuff. This is a combination of solving logs but also condensing logs. Okay, so we have 2 logs that have the same base. Since there's a plus sign in the middle, we're going to multiply. So we have log base 4 of 12x equals 4. All right, now like what we did in question number 14 there, all right, we're going to smash the log. The 4 as a base becomes the base of the exponent 4, so we have 12x equals 4 to the 4th power. All right, well, 4 to the 4th power is 256. That equals 12x. Divide both sides by 12, and x will equal, let's make that a fraction, 64/3. Okay. And then finally, number 18, same idea here. We have to make, well, there's no condensing. We're going to smash the log. The x will become the base of the exponent on the other side, so x squared is equal to 49. Well, what number gives you 49? If you square it, that would be 7. And that is solving the solving standard for Power Standard 5.